Hi, and welcome to my channel. My name is Leo, and I'll be your resident geek. In the next couple videos, I want to set a new baseline standard for making carbon-based batteries. In other words, I think I've got a method that should work consistently and solidly. I want to share that method. I'm going to share it in a way that does not require you to have watched my previous videos, so that we can have a new baseline and we can take it from there. Ideally, I would be encouraging people to do their own experiments and that we can share the results and that we can grow together and make better and better and better batteries. So that's my hope. Now, this video is an interesting one because I'm going to describe the materials and the tools that I'll be using in the next couple of videos. It's going to take me probably a couple weeks to get through the next couple of videos. I have a day job and a busy life, but I'm hoping that this will be of value. So in terms of materials, the materials that you'll want to gather to be able to do these kinds of experiments with me. One of them is aluminum foil. Now, in the past, I've used a material called Graphite, which is graphite foil. Very nice material. It's wonderful because it doesn't have any problems with salt water and things like that. However, it's harder to get. It's a little more expensive. It's not as conductive. So I'm going to be using, for the electrodes in this one, I'm going to be using just heavy-duty aluminum foil, the kind you can get at any grocery store. I suggest the heavy-duty because it is thicker and will be more conductive because of that, and also a little harder to rip and harder to mess up. The next thing is 3M clear shipping tape, and I will have a list of all these things down at the bottom below the video. 3M shipping tape. It doesn't have to be 3M, any brand will do, but the bottom line is that I'm looking for a thick tape. I bought some off-brand tape, shipping tape, the clear shipping tape, that's about roughly 2 inches thick, 49 millimeters. I bought some of the off-brand stuff and it was too thin. It would rip and it was hard to work with and everything else. So I recommend the 3M in particular because it is thicker. But any of the thicker brands will be just fine. One material that I'm going to use is developed by Robert Murray Smith and his company. It's a special ink, and I'm going to be using it to adhere carbons to the electrodes. And also to protect the aluminum foil against the salt water. So I know that's a unique thing. You don't have to use it. You could indeed use just a binder and water, put it together and make a mixture, make an ink, and use that directly on the electrodes. That's cheaper. You could use, in the past I've used Titebond 3 wood glue because that's more waterproof. If I really, really wanted waterproof, I could use a urethane, especially something like Minwax spar urethane, designed to be used on boats. And those are cool, and maybe I'll go into that in the future. But for this set of experiments, I'm going to be using the special ink from Forward Working Group, and they make an ink that has graphite in it in order to be conductive and have some charge carrying capabilities, and then it also has graphene in it, incredibly conductive things that will go between the graphite, if you will, to make it even more conductive. It's also been made to be water resistant, which helps it in terms of protecting the aluminum foil. So you can get that from workingink.co.uk. So I strongly recommend that ink, even if it's just to play with. It is a wonderful conductive ink that you can do all sorts of things with it. And Robert Murray Smith has a lot of videos on his channel and Working Ink's channel and various places like that that describe some of the things you can do with it. The next thing, I'm going to be making a carbon to adhere with the inks, And that carbon, in my case for this start baseline battery, will be made out of sugar. Good old granulated kitchen sugar. That stuff is really good at producing carbons and also producing them in a way that seems to work pretty well. I'll be using salt, good old normal table salt, with the sugar to help enhance. I'll be using a microwave oven to convert it, so I'll be using salt to enhance the action of the microwave. I'm using the kind without iodine powder. I don't know that that makes a difference. I've never tried it with. I will also be using a little bit of graphite powder. This powder is typically used for like lubrication and some other uses, but in our case it just makes the microwave go crazy. It is wonderful at making it an incredibly robust microwave cooking thing. It basically is setting off little lightning bolts down within the powder, and so it makes it get extremely hot very quickly, and makes a good change to the graphite, the whole mixture that we're trying to make. I'm also going to be using just a little bit of urea powder, and these things are all available. They're available at Amazon.com, Walmart.com, eBay, lots of different places. So I'll be using a little bit of urea. I've tried it without the urea and it works better with it. I think what the urea is doing is actually releasing a little bit of non-oxygen stuff so that the carbons, as they're forming, don't just burn away, but they are able to work better. I think it helps that mixture. Now I'm going to use something different. In the past, what I've been using for my electrolyte has been table salt. And you can use that. You can use a 1 molar concentration of table salt. My understanding is, and I'm trying it with this but expecting it because I'm hearing it from really good sources, in particular Robert Murray Smith, that sodium sulphate instead of sodium chloride. Sodium sulphate is a better electrolyte by far, kind of a standard electrolyte that then people improve on even from there. And so I'll be using what's called a 1 molar mixture. I'll get into it when I'm actually using it. A 1 molar mixture of sodium sulphate. I will also need some coffee filters because I have to, after the microwaving, and what happens is the sugar starts off as a powder. It expands greatly. It's kind of like a sugar snake, like you've seen in some YouTube videos perhaps. But it expands greatly. We grind it on down and we filter that to get rid of the salt. We don't want the salt in there, we just want the carbons. So one way that I found is by running it through a coffee filter and just pouring water through it. I found that it's really nice because it's an automated method to use an inexpensive coffee maker. It's not hurting the coffee maker because all the coffee maker is pouring through it is water. And it's just going through the filter. So you could even use it for coffee, although I would tend not to, but you could. It doesn't hurt anything in the coffee maker. And finally, the last supply I'll need is distilled or deionized water. In most cases, they're very similar. I'll be using distilled water because it's so much easier to get. And for in most cases, they're pretty much the same, but not always. I mean, but I'm taking that risk and I'm thinking it's going to be okay. But that's it. Those are all the supplies that I need. Then I need a bunch of tools. One tool I need is a microwave oven, which I have. I mean, I have all these tools, but I'm just sharing them for you. Is a microwave oven. Now, choose a cheap microwave oven that you can dedicate to this task. It's smoky. The task is very smoky. You're basically burning sugar. And so it probably caramelizes and then carbonizes. And so it's a very smoky process. You'll want to do it in an extremely well ventilated area. I just take the microwave oven outside. But a microwave oven to cook the stuff. There are lots of alternative methods. You can use a hydrothermal carbonization, where you have basically a pressure vessel and it's baking in an oven about 450 degrees for several hours. You can use a kiln and methods like that to carbonize. For me, I love microwave ovens because they're cheap, they're accessible, they're everywhere, and that's part of what I want to do. I want to do something that's clean and cheap and safe. Next, I'm going to be using a coffee grinder or spice grinder, one of those just little cheapy things that because a lot of times I'm going to want to grind up my powders, things into powders and make it happen. I've noticed they also do a good job of mixing things. For example, when I take my mixture for the sugar of the salt and the sugar and the graphite powder and urea, then I put it in the grinder and it grinds it up. It breaks up the crystals even finer, but it also provides a mixture. So that's good. You're going to want ceramic tiles. We're going to be cooking it in ceramic mugs, which you're also going to want. You're going to want ceramic tiles to go on top of the mugs. And also in the microwave oven, you want them underneath the mugs to protect the glass of the microwave oven. So fortunately that you can get them really cheap. They're like $1 each and 50 cents each for the smaller ones that cover on the top. At least right now where I live. You're going to want to have some way to have a template for cutting your electrodes out of the foil. You're going to want to be able to do a good job with that, to be consistent with that. I've got little 3D printed tiles, but it could just be a piece of paper. It's fine. Just make it to the right size and you're golden. You're going to want to clamp your battery to get a good contact, to push everything into good contact. And so I'm going to be, I have 3D printed these little squares. I love having a 3D printer. It makes projects like this so nice. But anything about that size that you can put the clamps around to keep it stiff and spread out the clamping force so that it's even across the whole surface of the battery is going to be fine. You're going to need some way to charge and to test the batteries. Now I've got other videos on this with my little charger load device, and that's what I'll be using in my case. But I've used batteries in the past to charge, and I've used single LEDs to discharge, and those are available pretty much everywhere. A D-cell battery to charge it up and a little LED to discharge it. You can start with that, and then you can move on to other things. The little unit I built has a special, it has 12 volts coming in, and then has a special voltage step-down unit that can make it be 10 to 0 volts. I choose about 2. And then there's another side that is a load, and it has a monitor of the amps and the voltages coming out. But you can use any old meter, any old voltmeter, and put it in series or parallel, depending on volts or amps, and measure it that way. But you'll need some way to charge the batteries up and to test them and to see the result. You're going to need a fairly stiff brush to brush off the excess powder, carbon powder. You're going to need some ceramic mugs, like I mentioned, to cook. I use Dollar Tree mugs. I make sure I get the ones that are supposedly microwave and dishwasher safe. And even so, they typically crack. Even so, they typically break because the temperatures are just so dang high. I'm guessing that the little lightning bolts from some things I've read are about 3,000 degrees high, and the ceramic mugs can only handle like 1,200 degrees. So it's fun, it's cool, it's fine. And since the mug is $1 at Dollar Tree, then you can get cheap ones. Get cheap ones because you'll be going through them unless we figure out together some way to preserve them and keep them from breaking. You're going to want a kitchen sieve, little handle thing with the screen on it for sifting the powder over the top of the electrodes. You're going to want a rolling pin. I'm going to be using a nice marble pin because it's nice and heavy and very flat. But you're going to want to be rolling the material into the glue, into the ink. You're going to, and by the way, Robert Murray Smith has some fairly recent videos, very recent videos, where he's described these techniques and described using his ink. So I'm taking it to a little different way. I'm modifying some things and standardizing in my way, but his stuff is always so good, and he's such a good teacher. I highly recommend it. You'll want a spoon, because you've got the electrode and you're going to be rubbing the spoon on it to polish it, to collapse it. When you first put the ink on, it has a lot of water in it. And so it might go, like 4 mils thick. But as it dries, then the water goes away and it's still too thick, and you want to push it down so it's in tight contact, so everything is nice and conductive. So you gain a lot of conductivity. Everything works a lot better by using the spoon to calendar, it's called, to calendar the material. You're also going to want something to stir things with. You're going to need a cup or a beaker to hold the electrolyte. To do it my way, that I'm going to be using, which I'm copying right off of Robert, is you're going to want 2 threaded rods. These threaded rods you'll be rolling, and it makes this beautiful, smooth application of the ink. Much better than what I've been able to do in the past with brushes and everything else. Some people do great with brushes, and that's just fine, and it's cheap and you already have them, and so that's fine. But if you just get threaded rods, they work about as well as the special super duper wire round rods, the Mayer rods or whatever they're called. They're very expensive, and these are very, very cheap, and you can get them at the local hardware store. The 2 I'm using will be, I got stainless steel rods because I just want no interaction with the materials, and in 2 sizes. I'm copying Rob's sizes because even though we're on this side of the pond, we can still buy and use things in the metric system. So I'm getting the M4 rod and an M14 rod. The M4 rod will provide a very thin coating. The M14, and we'll do that first and then calendarize it. And then we'll apply, after it dries, we'll apply an M14, which is a thicker coating. That's what the carbon powder will go into while it's wet, and then we'll roll the rolling pin over the top of that. Finally, a tool you'll definitely need is a scale, and preferably one that measures to 0.01 of a gram. I've got some really inexpensive scales. They were like 10 bucks. Off of eBay that weigh up to 500 grams. They say that they go to 0.01 grams. I suspect that their accuracy is really more like 0.234, depending on how much the weight of the thing you're measuring. But even so, that's still half a gram or better of measurement. It's nice and consistent, and you can really dial things in. And having that repeatability is crucial. We're going to be taking a lot of time to be getting things just right so that we can do it over and over again. When I built batteries this summer with the kids, then I teach a summer day camp, a summer science day camp. Well, when I did it, lots of variability. So I'm learning a lot about, okay, this part of it needs to be ultra precise. This part you can have more variability in. There's a couple of optional tools that I recommend, but you may optional. One is a fire brick, just a little 3/4 inch little fire brick, this by 3/4 inch. I put it underneath the mugs as I'm microwaving them, and it helps protect the oven. The mugs get crazy hot, and they're so you don't want the glass in the microwave to break. You don't want to transmit that heat directly into the microwave, and a fire brick works great. It's wonderful. It even, right after you take the mugs off, you can touch the fire brick and it's barely warm. I recommend, if you can swing it, and they're cheap. I got mine for like 30 bucks. A dehydrator. Of all things. It is wonderful because there's several stages where you need to dry things. You're going to need to dry your electrodes. You're going to need to dry them after putting the powder on, after the first application of the thin ink, and then the thicker ink with the carbon powder. You're going to need to dry them again. And then later on, after filtering, you're going to want to dry your material and be able to make it back into a powder. So lots of drying, and dehydrators work great at that. You can also just use a blow dryer on a stand, pushing down at it, but for me, just tossing it in a dehydrator, coming back the next day really works well. Finally, and this again is optional, you can use a coffee maker, like I mentioned, for filtering. You don't have to. I actually have also done filtering by using a coffee filter in a little device that went down into a Dixie cup and just pouring cold water through it. I think the coffee maker works better. You're dealing with hot water, and I kind of think that that's good for filtering. In this case, that might give a better filtering. Never tested it. Don't quite know how to test it, really. But it sure makes it easy and quick, because you just put it in, boom, you turn it on, you go away. You come back in 5 minutes, and you have a filtered bunch of powder. So that works really well, and then you just have to dry that. Again, I use the dehydrator. I just take the coffee filter and just open it up and put it directly in the dehydrator. Other thing that's nice about coffee filters is you can actually write on them notes about which sample is which. So when I have my whole class of kids, I just write the name of the kid on the mug on tape that goes on the handle. Because the around part of the mug gets, if you put tape on that, it becomes black because it's too hot. The handle stays just cool enough that you can put blue tape on it, and you can write the name of the kid, and then you can transfer that. You can take that name off that tape, and you can put it on the filter paper, and can keep control of whose sample is whose, and keep as they're making their batteries. So lots of fun. Oh yeah, another supply you'll probably want is like a Sharpie, something to write on, but that's fine. They're readily around. So lots of fun, though. We're going to have lots of fun, and I really think that we should have a solid battery as a baseline. And then you start experimenting. All sorts of places we can experiment. We can change electrodes, we can change carbons, we can change electrolytes. We can try the graph versus the aluminum foil, and all sorts of different things. But I'm trying to start with something that I have a pretty good confidence in working and being solid. So this should be a lot of fun, and I'll see you in the next videos. Thank you.